Hi again, we have our AP Stats prep for the exam. So question number 1 from week 8 is we're going to assume all the distributions above have the same range, okay? So basically whatever we decide the lowest is, say 60, highest being 100, they'd all have the same basic low and high, okay? Now, the first question is, which shape best describes each of the distributions? So I'll go through. A is considered a uniform distribution. What that means is that across the entire range of scores, relative frequency of each of the scores is pretty close to each other across the whole range. Okay, so that's uniform. That would indicate that the relative frequency at each location across the range is approximately the same. Now we go over here to normal distribution, B. So what you see is, compared to the rest of the distribution, this lowest value here for this to the left, it is not, you don't see it appear as many times, and that's the height of that bar is low to show that relative to the rest of the data, we don't see that one occur as often. The higher the bar, the more often we see it occur in that distribution. So right here in the center, we've got a normal distribution because it's bell-shaped. Highest in the center, lowest in the tails. C is different. C is bimodal. Bimodal has kind of two modes is what it's really referring to, and symmetric. Symmetric means it's about the same on both sides. So both peaks are about the same height. There is such a thing as a bimodal asymptote. So let me just show that. Off to the side here, we'll take a look at something that might be bimodal asymmetric. Okay, so here we go. So we have kind of a peak right here, maybe a few middle, and then maybe another peak over here, but it's not quite as high. Now we know that we learned that the mode was the highest frequency, but when we get to more advanced stats, we understand that, okay, their modes really are a collection, kind of an area of the distribution where there's a high frequency. So this is one of the modes, this is the other, but they're not symmetric. Okay, so this would be bimodal, but asymmetric. Okay, so this was bimodal and symmetric because it's approximately the same on both sides. And then D is supposed to be skewed right. All right, so now on to some of the other questions. All right, why does distribution A have a greater standard deviation than distribution B? All right, so real fast here. What we're going to talk about is standard deviation measures the typical distance from the center. So in these cases here, okay, both distributions, the center is right down the middle. It's approximately where we expect the mean to be. In a symmetric distribution, we do expect that the mean will be right in the center. Okay. Now, standard deviation measures typical distance from the center. And what we're noticing is, relative to the rest of the distribution, in distribution B, you don't have a lot of scores far from the mean, right? You don't have a lot of scores way out there. That's what this low height means. But however, in distribution A, we have a relatively high frequency of scores far from the mean. Now, this is far from the mean, right? These scores here are far from the mean, so are these. And what you're noticing is a relatively high frequency in distribution A. In distribution B, we have a low frequency of scores that are far from the middle. And that's what's going to make the standard deviation in distribution A higher. That's what that's basically saying there. All right, explain why distribution C has the largest standard deviation of all of them. All right, so what we have is, again, two modes. A big collection here and a big collection there. What we're saying is, relative to the rest of the distribution, there is an extremely high number of scores that are far from the mean. That's in a low number of scores near the mean. Right? These scores near the mean actually, once you put them across the whole distribution, they actually, scores in the middle will bring the standard deviation down a little bit. Okay, scores far from the mean will bring the standard deviation up. This distribution has a lot of scores far from the mean, very few scores close to the mean. Okay, so that's going to be the highest of all. D, it is going to have a higher standard deviation, I believe, than probably A. Definitely going to be higher than B. Okay, hard to tell if it's going to be higher than A. It might not be. But in D, we go for a different question. Typically in stats, we prefer measures of center and spread to be mean and standard deviation. It's just in our course, that's what that's what the majority of people would use in statistics. There are statisticians out there that do know some methods with median and IQR. We just don't use it in this course unless we have to. But in this case, in D, why is it more appropriate to report the median and IQR for our measures of center and spread? Okay, that is because of the skewness. Skewed right distributions. I'll show you an even more significant one. For skewed right distributions, okay, what we'll do is we'll make it a little bit more. So that would be a skewed right distribution. Now, the middle of this distribution is really right in the center of that hill. That's approximately where we want the center to be considered. Okay, but what's going to happen with skewness is this tail, okay, these scores out here are going to pull the mean out of the center. So the mean is no longer going to be, a good measure, a good summary statistic of where the center might be. If we predict a random value in this distribution to be here, we're going to be wrong a lot more often because of the high frequency of scores over here to the left of it. So the center is right here, but the mean is pulled out of the center to kind of make up for this tail or this extra data that's far from the center. So in that case, median is a little more resistant. Now, median might get pulled some, but it's still going to probably be pretty close to the center. It's going to be more resistant, which is what we learned last week. Now, it's not really appropriate to report standard deviation with median. If you did, somebody would think, well, they really aren't using the right summary statistics together. If you're going to use median, you really should use IQR with it. If you're going to use mean, then it's appropriate to use standard deviation with it. So that's it for that first question. Question 2. All right. Now, given that the distribution is approximately normal, the mean of 42 and a standard deviation is 6.5. Give a point prediction for a randomly selected score from this distribution and explain your choice. Okay, so I would predict, really simply, 42. So if I have a normal distribution, think about it, that highest frequency of scores is in the center, right where 42 is. So in a normal distribution, the mean is right in the center of that hill. So that would be our best guess. The most scores are at or near 42. Okay. So in a normal distribution, highest frequency scores is at or near the center. Mean is in the center. So predict the mean for a randomly selected score. All right, next, give an interval prediction. This is more relevant, and we should also, even though it doesn't say so, we should also give kind of an accuracy level. How likely is it that our randomly selected piece of data is in our interval? You're almost talking about something like a confidence interval at this point, but not really. So what I did was, for an interval prediction, I might say something like, well, let's go one standard deviation below and one standard deviation above the mean to predict right here. Okay. Why? 70%, well, actually 68% of scores in a normal distribution are within one standard deviation of the mean. 35.5 is one standard deviation below the mean. 48.5 is one standard deviation above the mean. Okay.